In this video session, I would like to explain about the heat and work grades. Now, heat and work grades uh, are explained with the help of second law. The first law is not sufficient to clearly differentiate between the heat and work as with respect to the grades. So, first law states that change in process, change in state, change in state. So, the cause is supplying of heat Q in to your body, and this Q in is used to raise delta U, change in internal energy, and some work will be supplied. The work or heat will be sent out of the system. So Q heat is low grade energy. Why? Because this Q cannot completely convert into work. But as per the Joule's experiment, the work input is completely getting converted into Q. So the first law only says that if you are supplying some amount of heat to the system and the system will absorb the same amount of heat, and here this heat is not completely converted into the work. So that is the reason why this is called a low grade energy. But whereas if you supply some work to the system, this work will be completely converted into heat. Because of this, the heat input to the system will be used to generate temperature gradient. And similarly, the water at higher potential will be the cause of flow of water. And electric current is the cause of potential gradient. So in this system, so you can say that you can differentiate the heat and work like this. If there is a system, because of some input energy to the system is changing state from state 1 to state 2. So if this is Q12, and if you are getting some W, and when 2 is coming back to 1, and W21, so it says that Q12 is greater than or equal to W21. And for this reason, heat is low grade energy. And in the same case, 1 to 2, because, and here, if you are supplying some work input 1 to 2, and you are getting some Q21, so W12 is equal to W21. So that's the reason why work is high grade energy. So according to that is here cannot define the second law of thermodynamics. So what's happening to the remaining, the Q12 is greater than W12. So the remaining amount of heat is being rejected to the atmosphere. That is what is explained by the Sadi-Carnot. What he is saying is, whenever you are supplying some heat to the system, It is steering from state 1 to state 2, state 2 to state 3, state 3 to state 1. And here Q12, in Q12 is supplying heat, in Q23 W23, here we are getting W23 amount of work, and some amount, the remaining amount, because Q12 is greater than Q23, Q31 amount of heat is rejected. So that is how the Carnot defined the second law of thermodynamics, and because the only reason that the process is not being, the process of the change of state is not being clearly explained by the first law of thermodynamics. That is what I will discuss in this small video session. Thank you very much.